Welcome! In this video, we'll walk through how to solve the radical equation you see on the screen. Our goal is to find all possible values of x that make this statement true. By the end of this video, you will be able to solve radical equations with two radicals. Solving equations with radicals can be tricky, so we need a systematic approach. The main idea is to get rid of the square roots, which we can do by squaring both sides of the equation. However, there's a crucial step we must take first to avoid creating an even more complicated problem. Here's our equation again. If we tried to square both sides right now, we'd have to square the entire left side, which is the sum of two radicals. Squaring this term means we would need to use the binomial expansion formula, a plus b squared equals a squared plus 2ab plus b squared. This would result in an equation with the square root of a product, which is still a radical equation and can be harder to solve. So that's not our first move. Instead, the most effective strategy is to isolate one of the radicals before squaring. This way, squaring that side will eliminate one radical, simplifying the equation significantly. It's a key technique for these types of problems. Let's move the second radical to the right side of the equation. We can isolate one of the radicals, let's say the first one, by subtracting the second radical from both sides. We are essentially isolating the radical. Now that we have one radical isolated on the left side, we can safely square both sides of the equation. This is the main method for getting rid of radicals. Let's square the entire left side and the entire right side. This step is crucial because it allows us to eliminate the radical on the left. On the left, squaring a square root cancels the root. So, root x plus 1 squared is simply x plus 1. This gives us a much simpler expression on the left side. Notice how the radical is gone. Now let's expand the right side. Remember the binomial formula, a squared minus 2ab plus b squared. Here, a is 2, and b is the square root of 2 minus x. So, we have 2 squared minus 2 times the square root of 2 minus x, plus the square root of 2 minus x squared. Let's simplify this. 2 squared is 4, and root 2 minus x squared is 2 minus x. This simplifies our equation to x plus 1 equals 4 minus 4 times root 2 minus x plus 2 minus x. See, we still have one radical, but the equation is much cleaner. Let's continue to simplify our equation and consolidate the terms. Our goal now is to get the remaining radical by itself again. This is our current equation. We can combine the constant terms on the right side. Combining 4 and 2 gives us 6, so we have x plus 1 equals 6 minus 4 times root 2 minus x. Now, let's work to isolate the radical. First, we can add x to both sides. Notice that the x's on the right side will cancel out. This leaves us with 2x plus 1 equals 6 minus 4 times root 2 minus x. We're getting closer to isolating that last radical. Now, let's subtract 6 from both sides. We are moving all terms that don't involve the radical to the left. This gives us 2x minus 5 equals negative 4 times root 2 minus x. The radical is almost completely isolated. This simplifies the equation significantly. We've done a great job simplifying the equation down to its last radical. Now it's time for the final push. We will square both sides one last time to eliminate the radical for good. Here's our simplified equation. Before we square, let's divide both sides by negative 4 to get the radical perfectly isolated. This will make the squaring process cleaner. Dividing by negative 4 gives us a fraction on the left, which is perfectly fine. The key is that the radical is now alone. The negative sign has been absorbed. Now we square both sides again. This step is designed to eliminate the square root. On the left side, we square the numerator and the denominator. On the right side, the square root cancels out. Expanding the top, we get a perfect square trinomial. Squaring the denominator gives us 16. The right side is simply 2 minus x. Notice that for the first time, our equation contains no radicals. This is a huge milestone in solving the problem. We've eliminated the radicals and are left with a quadratic equation. Our next task is to solve it. Let's arrange it into standard quadratic form. ax squared plus bx plus c equals 0. First, let's multiply both sides by 16 to get rid of the fraction. This will make our coefficients easier to work with. Distributing the 16 on the right side gives us 32 minus 16x. Now, we need to gather all the terms on one side. Let's move everything to the left side by subtracting 32 and adding 16x to both sides. Combining our like terms, negative 20x plus 16x is negative 4x, and 25 minus 32 is negative 7. This gives us our quadratic equation in standard form. 4x squared minus 4x minus 7 equals 0. This equation doesn't factor easily, so we'll use the quadratic formula to find the values of x. It's a reliable tool for solving any quadratic equation. Let's apply the quadratic formula to find the solutions for x. The formula states that x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. From our equation, 4x squared minus 4x minus 7 equals 0, we can identify a, b, and c. Here, a is 4, b is negative 4, and c is negative 7. These are the coefficients we will plug into our formula. Substituting these values gives us x equals negative 4 plus or minus the square root of negative 4 squared minus 4 times negative 7, all divided by 2 times 4. Simplifying inside the square root, negative 4 squared is 16. Negative 4 times negative 7 is positive 112. So we have 16 plus 112. This gives us x equals 4 plus or minus the square root of 128, all over 8. We can simplify the square root of 128. 128 is 64 times 2. The square root of 64 is 8. So, root 128 becomes 8 root 2. This simplification gives us x equals 4 plus or minus 8 root 2, all over 8. Finally, we can divide the 4 in the 8 root 2 by the 8 in the denominator. This gives us two potential solutions, x equals 1 plus root 2 and x equals 1 minus root 2. These are the solutions to our quadratic equation. We found our two solutions from the quadratic equation. But we're not done yet. Whenever you square both sides of an equation, you risk introducing what are called extraneous solutions. An extraneous solution is a value that satisfies the transformed equation, but not the original one. We must check our answers. This step is a must for any radical equation problem. First, let's consider the domain of the original equation. For the square roots to be real, the expressions inside must be non-negative. This gives us x is greater than or equal to negative 1, and x is less than or equal to 2. Our potential solutions, 1/2 plus root 2 and 1/2 minus root 2, both fall within this domain. So that's a good start. Now, let's substitute each solution back into the original equation and see if it works. First, let's test x equals 1/2 plus root 2. Substituting this in gives us a long expression with many nested radicals. We could try to simplify this, but there's a more efficient way to test. Let's use the decimal approximations. Root 2 is about 1.414, so our solution is approximately 1.914. Plugging this into the original equation, we get the square root of 2.914 plus the square root of 0.086 equals 2. Let's calculate these values. The first radical is about 1.707. The second radical is about 0.293. Adding them, we get 2.000. It looks like this solution is correct. The values are approximately equal. Now for our second solution. Let's test x equals 1/2 minus root 2. This is approximately negative 0.914. This value is also in our domain. Substituting it in gives us the square root of 1.086 plus the square root of 2.914 equals 2. Let's calculate. The first radical is about 1.042. The second is about 1.707. Adding them gives 2.749. This does not equal 2. The second solution we found from the quadratic equation is extraneous. It does not solve the original equation. It's only a solution to the transformed equation, which is why we must always check our work. So, the only valid solution to the original equation is x equals 1/2 plus the square root of 2. Let's quickly recap the steps we took to solve this radical equation. First, we isolated one of the radicals. This was a crucial first step. Second, we squared both sides to eliminate that first radical. This simplified the equation, but left one radical remaining. Third, we simplified the resulting equation and isolated the second radical. Fourth, we squared both sides a second time to remove the last radical, leaving us with a standard quadratic equation. Fifth, we solved the quadratic equation, which gave us two potential solutions. And finally, we checked each solution in the original equation to identify and discard any extraneous solutions. This final check is essential. By following these steps, we successfully navigated the challenges of a two-radical equation and found its correct solution. I hope the step-by-step guide has been helpful.